take a picture of this really fast so that people can see it, because I forgot to do it. Okay, 3.2 is the next one. 13.2. Did I just say 3?
That was a long time.
Wow, that was a long time ago. I'm living in the past.
I'm like going back in it.
13.2. So this one is just talking about circumscribing a quadrilateral, okay? So this is circumscribing a quadrilateral. Okay, the easiest quadrilateral to do a circumcenter on is a square. Okay, to do a the easiest one to do on is a square, because if you just find the middle and go out here as the radius, it's gonna just go around and touch all the points. So that's an easy one to do. It's the place where the you can actually take the diagonals and where the diagonals intersect. It is also where the perpendicular bisectors intersect. It will give you the same thing. So a square is actually pretty easy to do. Okay. A rectangle is a little harder to do, but again, if you take the perpendicular bisectors and find the perpendicular bisectors, this center point right here, out to here will be the circle. I'm not doing a good job, but it will be, well, you know what I mean, okay? So again, the perpendicular bisectors are how you find it, okay? So a rectangle's not too bad because you've got 90-degree angles. Okay. So let's look at a parallelogram. And this is where it gets tricky. So if I want the perpendicular bisector of this, right, that's not perpendicular. Okay, perpendicular would come down here of that one, perpendicular of this one. Perpendicular of this one would be, how would I do that one?
Like jumping around. You want to slam it to the window?
Oh, that's not right. That didn't, yeah, it did bisect them. Perpendicular of this one. Okay, so it's not as, there is no perpendicular bisector congruent things here. Okay. That's because you cannot draw a circle, because if I put my circle here and go out to here, that radius would be different than this. So there is no way to draw a circumcised circle around a parallelogram, okay? Okay, get your heads out, don't even go there, okay? Okay, so no way to do it, okay? Well, let's look at a regular trapezoid.
Is it because those two outer points are farther out than the
Yes.
smaller ones? Oh, okay.
Yep, because this here is longer than this, okay? So that length there, the length is shorter than this length.
Oh, is that because it's like angled?
Yeah,
Like
because
a
it's
hypotenuse,
angled.
basically?
Yeah. So what happens is I can't draw a circle because I can't find a radius that will, or a center that will be equal so that it hits every one of these points. Okay, so it just doesn't work because If I move it down here to catch those three, it will definitely not catch this one. Okay, so you could move it all day and it won't hit all of them. And it has to be in the center because I can't put it outside. How will I ever hit that fourth point? Okay, can't do that. Okay, so it does not work. You cannot do a quadrilateral like that. Okay, this is a regular trapezoid or an isosceles, I'm sorry. Isosceles trapezoid. So if I take the perpendicular bisectors here, which will be, because it's isosceles, can't get that drawn, but it should be equal like that. You're gonna find 1, okay? Then I want, and if I keep that going down, I can't do it that way. The perpendicular one's gonna come here, and this perpendicular one is gonna come about here. And actually the distances now are the same, so you can make one that's right on the base of the isosceles. So it can be done. Yeah, you know, I can't draw. You just have to excuse my drawing. You can try these later with your compass and your protractor if you want. What do you notice? So this may be harder than it can do it, but the ones that can be circumscribed, the quadrilaterals that can be circumscribed, are the ones, so some cannot be. Not all quadrilaterals can have a circumscribing circle. Okay. What it turns out to be is that the ones that can are where the adjacent angles, No, opposite angles are supplementary. So where the opposite angles, so the ones that can be quads that can be have opposite angles that are supplementary. What does supplementary mean? So what does that mean in layman's terms? They're supplementary.
I don't know what it.
Oh, isn't that where they make a 90-degree angle or
Nope, that's not.
180?
It's 180. So basically this says the two opposite
Supplement.
angles
To get to 180
add
complementary angles.
to
I don't know.
180 degrees. Okay, that's what that says. The supplementary is the angles equal 180. These are the opposite angles. So in other words, another way of saying instead of opposite angles that are supplementary is that the two opposite angles add to 180 degrees. Those are the only ones that can have a circle that goes around and connects every one of their vertices. Okay, yes.
Can you find an oval?
Yes, you can find ovals. We're not doing that. So ovals are different, and we will kind of talk about those if we have time. I'd like to pull that in, but right now we're kind of going through this. But yes, you can find ovals. It's a different process completely, and that's what's interesting. Okay. So yeah, here you probably could find an oval that goes out. I'd have to explain to you how you get that, and there's a lot of different things to go to get that. Okay. So that is what we can do with quadrilaterals. So as long as you know they're supplementary, then you know that you can find a circle that goes around them. Okay. I will just say this is not used as much except for package designers do use things like this to figure out if they have something circular as a package and what is the maximum thing they can fit into it? Okay, what's the maximum square? What's the maximum? Of course, the square will be the biggest, but you can also figure out what's the rectangle. You have more wasted space. But so sometimes these things are used when they're doing packaging of stuff. And so that's something to realize what these kind of things are used for. Okay, they are used, just not by a ton of people. It's people that have to think about packaging or how we're going to place things, especially, what's the maximum usage of this package, that kind of stuff.
So if you wanna work for FedEx, you better take notes.
Actually, no person who works for FedEx.
Okay, we got time.
I actually know a person who works for FedEx. She makes 6 figures too. She's like in management.
Okay, I'm gonna go ahead and go to 13.3, I mean, not 3.3 again, I'm back back
What is-
somewhere.
On lesson 2, it says cyclic.
Oh,
quadrilateral.
okay.
What is that?
Cyclic means they can have a circle put around them.
Oh.
Okay, that's all that means, okay?
Are we gonna be quizzed on this?
So now,
Because that's like a control and a
this
helicopter
next
called a
one, remember the first one we talked about, concurrent lines, was the perpendicular bisectors
In circles.
of a triangle. And what that gives you is the circumcenter of the circumcised of the circle that circumscribes and for right now we're just doing triangle, okay? So that was the first one we did. Remember I said that this whole section is about concurrent lines, okay? So the first set of concurrent lines is the perpendicular bisectors of a triangle, okay? The second set of concurrent lines are the angle bisectors of a triangle. Okay, that's the line that cuts your angles in half. Okay, and they will all meet in the center also. So if you're looking at any triangle, take this one, and I cut this angle in half, okay, I'm cutting this angle in half, that's harder to do. I'm cutting this angle in half. Oh, look at that, they matched up. Okay. So if you cut, that is not exactly in half. Okay, so that's why it was not. That's actually better, right there, okay. Freehand drawing of these, it's harder, but you can kind of get the idea. If I cut each angle in half, they meet right there, okay? So they are congruent, or concurrent lines, okay? They form a special circle also. This point here is a center of what's called an inscribed circle, okay? An inscribed, so it's the center, this point, the point is the center of an inscribed circle. Okay. So when we're looking at that, this point, the center, the center is also called, so the in center is the name that's given to this point. It's the in center because you're inscribing. So remember up here, it was the circumcenter. You just take the scribe off and put center on it. Here you take the scribe off and put center on it, and that's the name of the center point, okay? So this is the name of the center of the circle. Okay. And what an inscribed circle it's not going around and catching all the vertices. It's inside the actual triangle. So it's a circle that is tangent or tangent to each side. In other words, when you draw the center of the circle, it will be in there. I don't know how. So it's going to be in there. This is going to be a tangent line. The sides of the triangle are tangent to the circle. And if they're tangent to the circle, then there's a lot of things that you can find out about it, because remember, from any point, these links are going to be the same, right? Any point where it's tangent, those links are going to be the same. So really, if these points right here where they touch are all tangents, these lines are, so this is going to be perpendicular to it. And so you can come up with that these links are the same, these links are the same, and those links are the same from your triangle. Okay, based on the fact that they're tangents. And tangents from the same point always are equal length. Okay, which is what we reviewed before. So that's really what you do there. So if you bisect every angle, you'll find a point that will give you a circle that will be inscribed in the triangle. In other words, it will touch every side once, exactly once. That makes the sides tangent to your circle, okay? And the center of that circle is called the in center because it's part of the inscribed circle, okay? So circumscribed means you're going on the outside. If you think of circumference, circumference is the distance around, okay? So you're going around something. So to circumscribe a triangle, you're going around the triangle, but you're including all the vertices. Inscribed is where the circle is inside. That one to me is the easiest. I have a tendency to forget the name of the one on the outside, but this one's easy because it's inscribed. It's inside the circle, okay? Its center is called in center. It's made by the angle bisectors, being concurrent, okay? And the inscribed circle is tangent, or the inside circle touches each line at one point, which makes those lines tangent. Okay, does that make sense on that? Okay, so those are some of the things that you can look at.
Question.
Yes.
So when there's in center, it says name, and what's that?
It's the name. I don't know why I wrote that. It's the name of the center of the circle. I don't have any idea where that D came from. That was like, you know, when you're texting sometimes and it puts extra letters in for you and it drives you nuts. That's where that D came from. It was my texting app did that.
I usually hit P instead of a period because I won't hit the thing to change to where I can see the period. So I'll just
Right,
hit the
so
letter that's
annoying.
there.
Yeah.
Just be. I'll just end every message.
Stands for
Peak,
Exactly.
peak, that's the end, huh?
Yeah.
The end. A new symbol.
I hate when the
What?
autocorrect.
He's dying.
Dude, I hate when the autocorrect changes the word completely, so you say something like completely random.
I know, right?
Yeah, like you
Completely
tried to
out of
type
context.
something in German to be funny and then it said something like completely
Yeah.
horrible.
What?
Isn't that what they said?
Yeah.
Or when you accidentally text the wrong person completely.
Oh,
No,
dude,
that's
that's
the
why I never
worst.
asked my phone, cause like I asked my
Oh,
phone,
there's
text
two
this
more.
person and say this,
Bro,
and then it's like, do you wanna send it? I'm like, yes.
And it says
Okay,
it to
everybody got
someone.
it down? Ready? Okay, we're gonna
And you
go
can't
into
tell me.
two more sets of concurrent lines. I lied. I said there were 3, there are 4. But the next 2 don't have anything to do with circles. Okay, they do have special names where they meet. They do have stuff to do with triangles. These all have to do with triangles, okay? So far we've done the angle bisectors of the sides, or the perpendicular bisectors of the sides. We've done the angle bisectors of the triangle. They all meet, okay? So our next one, there's 2 more. First one is of a concurrent. Lines are the medians of a triangle are concurrent.
Is this still 13.3?
This is 13.4, sorry, I'll put it down here, 13.4. Okay. Somebody tell me, what is a median?
between.
Isn't it like when there's usually like something in the middle of the road that
Yeah.
separates like
What's the median of a triangle? That's going back, now we're refreshing, we have to remember, what is the median?
triggers that do.
Okay, so if I have a triangle, here's my triangle. The median is when it takes, you go from a vertex to the middle point of your other side, okay? So the median, a median connects a vertex with the midpoint of the opposite side. Okay, so if I take the midpoint of this side, which is approximately there, cover it, the midpoint of this side, see my beautiful drawing? So the midpoint means these 2 are equal on each thing. But they're not perpendicular. Notice these are not perpendicular. So they're different than the perpendicular bisectors because these medians are not necessarily perpendicular to the side. All they do is connect to the vertex. So it's from the vertex to the middle point or the midpoint of the opposite side, okay? That's just something that you know they are concurrent. And it's given a special point. This point where they meet is given a special name. The point where they meet is called, and I forgot, centroid. That's right, centroid. The
Like a stellar
Oh,
Yeah,
yeah.
it's like some
Okay.
alien cyborg.
So really, that's all they're talking about. The centroid is the point where they meet. There is no special circle that you get from that. You can't inscribe, you can't circumscribe anything from that point. It's just a point that you can look at right there, okay? It's given a special name, but they do all meet at a certain point. They're concurrent, okay? Which I think is fascinating. In a triangle, all these different things are concurrent. They meet up at the same point when you do them, okay? The last one that's a concurrent, the last one in a triangle is when you have the altitudes of the triangle. Okay, now what are altitudes of a triangle? Okay, the altitudes of a triangle are concurrent. Okay, so we have to review. What is an altitude? So if I draw my triangle like this, what is the altitude? How do I find an altitude? You guys remember what an altitude means? Another way we call it is the height of a triangle. How do I find the height of a triangle?
Can you make a right triangle?
Yes, you have to make, so altitudes are when you go from a vertex and you form a right angle with the opposite side. Okay, so that's an altitude. So it's from the vertex, so an altitude from vertex see, a line, okay, I'm writing this again. A line from vertex that is perpendicular to the opposite side. Okay, so in this case, from this side, to make it perpendicular, well, I kind of drew it almost as a right angle, so I guess it would be right there. Okay, so that would be our line. And if this is a right angle, then it's right there. So the point that they meet, so in a right triangle, you only have one altitude. Okay. Where they meet is called the orthocenter. Okay, so the point where they meet, what this is a lot about is all new terminology. Okay, so a centroid. So all of them have different ones. So when we're looking at this, the perpendicular bisects of the triangles, we have a circumcenter, that's the name of where they meet, okay? If you're doing the angle bisector, where they meet is called the incenter. If you have medians, where they meet, it's called the centroid. If you have altitudes where they meet, it's called the orthocenter, okay? So those are the different names of the points where those different things meet or are concurrent,
For the
okay?
orthocenter, it's just where the altitude hits
Where
the other
all
two.
the altitudes hit. This, because I drew it more as a right triangle, they're gonna just be that one, so it would be there, but not always. If you have a triangle more like this, your altitudes will meet probably more in the center. Your orthocenter will be in the center.
What about the centroid?
Yeah?
Is that just bisected angles?
No, remember it's the medians.
Oh, the median.
So remember, medians is where the centroid is. So medians, so first we have perpendicular bisectors. Okay? Then we have angle bisectors. So the first two are bisectors, okay? One is perpendicular of the sides, one is a bisector of the angles, okay? Those end up with centers of circles. That's why they're called the circumcenter and the incenter. They are actually the centers of some side of circle. This one is the circle that goes around the outside. This is the circle that goes on the inside of the triangle, okay? When you draw the medians, there is no special circle. So that's why it's called the centroid. Don't ask me how they gave it this name. Some bright mathematician decided to call it that, and that's why it's called that, okay? Altitudes is called the orthocenter. Again, there's no special circle that you get, hence why there's not the word center.
Does it have anything to do with your mouth?
I mean, ortho. I think ortho does mean right angle in some ways,
Oh.
because if you think about orthodontists, they're trying to make your teeth straight,
It's true.
which is actually perpendicular to your gums. I don't know, that's my guess.
Maybe.
I don't know.
That's my guess. I don't really know the
Yeah.
base number of ortho. I just realized this
Centroid
is
sounds
not
like
spelled.
some like
So,
alien centipede.
if they have center in them, they make circles. So circumcenter, incenter. If they don't, if they're just weird names, how do I remember? I don't, you could tell. I couldn't remember what was the median's name, it was a centroid. So yeah, write it down on your piece of paper, use it when you're taking a test, because do I remember it? Absolutely not. Do I use that? No. Okay. You use inscribed circles and circumscribed circles because you use them to do packaging and different things. They actually use, when you're doing the in-center, they start talking about, like, if you're making a house plan, how you put the stuff in the kitchen actually uses that when you're doing the drawings for that. You're looking for the shortest distance and you want a center circle there. So it is used. It's amazing how you use different things in different areas. But again, it's all measurement ideas. It's all things where you're measuring stuff. Okay. So we'll go with that.